Hey folks, thought we'd take a look at an example of integration by parts. I know we did several examples in class and we're going to do even more. But you know how I've been stressing write down the original integral followed by the result of integration by parts? I thought I would do one from the homework as an example to show you why that's important. So I'm here at the companion website I made for the class, and I went over here into the chapter contents. I'm in section 8.2. In fact, I've already gone to the exercises, and I thought we'd do number 24, integrating e to the 3x cosine 2x dx. So let me write the problem down. We're going to integrate e to the 3x cosine 2x dx. All right, so following my guidelines for integration by parts, the guidelines that I gave you, I think I'm going to let u equal the cosine 2x. So u is cosine 2x, and then I'll let dv be the rest. So dv is e to the 3x dx. We quickly compute that du, well, du is the derivative of u. Using the chain rule, we get du is 2, or I'm sorry, negative 2. So let me erase that 2 so I can get a negative in there, because derivative of cosine is negative sine. So it's negative 2 sine 2x dx. And v, the antiderivative of e to the 3x, well, that's a 1/3 e to the 3x. So here we go, cranking the original integral through integration by parts. So I write down the original integral, e to the 3x cosine 2x. And the result of integration by parts is u times v. So that's a 1/3 e to the 3x times cosine 2x minus, now it's minus the integral of v du. But you know, here in the v du, you have a 1/3 times a negative 2. So I'm going to go ahead and do that multiplying. Negative 2 times 1/3 is negative 2/3. And I'm going to rip it out in front of the integral sign. So that'll make that a plus 2/3 antiderivative of v du. So e to the 3x sine 2x dx. Hey, look at that integral we have, e to the 3x sine 2x. We get to crank that integral through integration by parts. So here we go, cranking that one through integration by parts. I'm going to let u equal sine 2x, and dv is going to be the e to the 3x dx. So we get du, okay, derivative of sine is cosine. Chain rule gives us 2, it's going to give us 2 cosine, well, I'm making a mess, 2 cosine 2x. So 2 cosine 2x dx. And v, well, we've already done that. We get a 1/3 e to the 3x. All right, now check it out. Here's what's happening. Our original integral, I've been stressing to write this down, so I'm going to write it down. The original integral, e to the 3x cosine 2x dx, equals, okay, from our first application of integration by parts, we know we're going to have a 1/3 e to the 3x cosine 2x plus a 2/3. Okay, and now we're taking this integral here and we are cranking it through integration by parts. So I'm going to now smack down a square bracket to put the result of integration by parts inside a square bracket. And you know u times v here, that's sine 2x times a 1/3 e to the 3x. So that's a 1/3 e to the 3x sine 2x minus, Okay, now minus the integral of v du. And just like before, notice in v du we have a 1/3 times a 2. So I'm going to do the 1/3 times the 2, which is 2/3, and rip it out front of the integral. So that gives me a 2/3 integral e to the 3x cosine 2x. All right. Hey, you know what? I'm going to distribute that 2/3 just to see what happens here. So let me scroll down just a little bit, give me a little bit more room. We have a 1/3 e to the 3x cosine 2x plus a 2/9 e to the 3x sine 2x. And then minus, it looks like 2/3 times 2/3 is 4/9, so minus a 4/9 integral e to the 3x cosine 2x dx. Well, check it out, folks. Look at our original integral. We started with the integral of e to the 3x cosine 2x dx. We just did 2 applications of integration by parts, and look at where we're at. We have a problem. We have the same integral e to the 3x cosine 2x dx that we started with. Okay, now we don't panic. We don't say, oh, we must have picked the wrong u and dv, in the first step. No, we don't. We treat it like an equation. This is an equation. There's an equal sign. There's an equal sign. The integral of e to the 3x cosine 2x dx equals this mess. So why don't we just go ahead and add the 4/9 integral e to the 3x cosine 2x dx to both sides of the equation. Treat it like an equation. Add that to both sides of the equation to get a 13/9 integral e to the 3x cosine 2x dx equals a 1/3 e to the 3x cosine 2x plus a 2/9 e to the 3x sine 2x. Just treating it like an equation. So now to solve for the integral e to the 3x cosine 2x dx, we'll multiply both sides of the equation by 9/13, and we get the integral of e to the 3x cosine 2x dx equals 9/13 times, the quantity 1/3 e to the 3x cosine 2x plus 2/9 e to the 3x sine 2x. And you know what? I better remember to put down a plus c. And then if you want, you can distribute that 9/13 on through, or you could factor out a 1/3 e to the 3x. I think that's what the back of the book would do, is factor out the 1/3 e to the 3x. But I'm going to stop here. I just wanted to show you there's a method of the madness while I've been telling you to write stuff down. Hope that makes sense. Thanks for watching.